So as it was stated, now I'm in my other hat. Now this is the kind of professional hat, Nokia. I'm working for Nokia, and I would like to talk to you about shift left. Oh, sorry, for you, shift left. This is an area where I had some problems already in the back end. By the way, these are my slides, Petra, right? So not PowerPoint karaoke again. Good. So why talking about shift left? We have a lot of problems, and I would like to talk about that, the kind of problems and the solution, and why I still believe shift left is important. A few weeks ago, I've been in the ISTQB General Assembly in Brussels, and I've been interviewing actually, a lot of people, what is shift left? And they said that, Szilard, this is old. We've been doing this for 30 years. And I said, yes, you are right. Shift left is old as a concept, but doing shift left, doing it properly, is still missing in many areas. On top of this, I believe we need to do shift left more proactively. And I will tell you why I call this concept as proactive shift left. You've seen me already on the stage. I would not like to go into introducing myself more, but the most important thing that I'm also a human being. I have my daughter, and sometimes we have a little chance as well, not only to test and work and organize conferences, but have a little bit of rest and test my skills on the horseback riding, right? Okay, so today you've heard about Nokia, right? The complexity, the areas where we are working with. I would just like to add something to that. If we are talking about the testing in Nokia, it's all about Comerstones. And by the way, would someone please start the timer for me? Otherwise, I will talk until evening. So the cornerstones of product and solution testing in verification in the testing area in Nokia are, we have very well-defined processes. Extremely good, very detailed processes. But I will show you why this could be also a problem. We have well-defined and very much standardized requirements. All our processes are ISO 9001 and TR 9000 compliant, which means we have a lot of bureaucracy as well. On the other hand, our quality management system is Lean Six Sigma. This means also a lot of kind of bureaucracy on one hand, but a lot of very good lean thinking, which is also needed for the shift left. On the other hand, we are working with very complex products, which needs to be highly available, 5.9 availability. Do you know how much is that? Actually, how little is the chance to have an outage? Every year, it's around 4.5 minutes. Right? Every one of you are actually want to have phone calls anytime. Our equipment, our telecommunication systems, which are providing the network, the mobile network, must be highly available. Right? Even during Christmas or especially New Year's Eve, you try to call the friends and the system is even overloaded, like double, 3 times. It's not crashing, it's highly available still. So we need to test the product in a way that at the end it will be highly available, and of course we need to develop the product in a way that it will be highly available. We are producing these products on cloud and also on IT hardware. Why cloud is more difficult? Because, you know, when we are talking about cloud, we just say that cloud is someone else's hardware. And that's true. That means you have no control on it. You don't know how it will behave. So this is, in a nutshell, the complexity and the area we are working with. So what was the problem and what is the problem? Why we are talking about shift left and why I believe it's important? Oops. On one hand, we have very well-defined processes, but these might result in silo thinking and losing responsibility. Why is that? Because people believe I am a security tester. so I do only security testing. The other one might say, I am a performance tester, so I deal only with performance. And a feature tester might say, I'm doing only functional testing. I don't care about security. I don't care about performance. I don't care about anything else. And by the way, what you see here is an entity or system testing, or the network testing, which is a system of systems testing. This is happening first, right? And this area happens after that. Wherever this area is not finding the faults early enough, there is this other team who will suffer. These guys, whenever they find a fault, they say it should have been found by you. And then we start the silo thinking and the fighting that who is guilty, who was not testing well enough. You see, we have a lot of different testing activities and a lot of different roles and responsibilities defined. I heard once a functional tester who really stated that I don't care about performance. It will be tested by them at the very end. The problem is when you find a performance fault, it's extremely difficult to correct it, to find the root cause. And maybe you need so big changes that you need to almost retest the whole system. The other problem why we need shift left can be seen based on statistical data. As I stated, we have very good processes, so we also collect process improvement data in our bug tracking system. This is a so-called should have been found flag, which we fill in for every fault, every issue. So looking to the customer faults, what you see is that majority of the faults stated like should have been found in an earlier phase. For example, of course not by the customer, but should have been found by system testing, or should have been found by functional testing, or module testing, or development, or specification. And this trend is very much visible, that actually each of the test phases are leaking to the next one. Meaning, we are not testing well enough in those phases, or at least the later phases are thinking you should have been found those bugs earlier. So this is a very good data and knowledge to understand what's the problem, what we can do with it. This is where we actually started to develop the proactive shift left thinking and concept. There is nothing surprisingly in this picture, but this is a test pyramid, right? You've seen this on many presentations, probably in different ways. There might be the acceptance testing on the top or the UI testing. I put our own test levels there. Network testing. Actually, the network testing is extremely expensive. Extremely expensive. We need very heavy equipments there, very expensive test laboratories. We need either real mobile phones, the real network, the real radio, the real everything, just to be able to test that, for example, a call goes through. System test is also very expensive. Here we have typically the full product, and we have simulators around it. So not the radio, not the real equipment, but simulators. And then on component test, of course, it's a module or unit or a component. The shape of static testing is this way because I believe we are not doing it enough. When we are talking about static testing, all the reviews of any documentation, any plan, specification, test cases, test plans, but also the code review and static analysis of the source code as well. So instead of this, which is already good, it's a pyramid. But I would like to see that we have a picture more like this. Much more lower level testing, much more component testing, and shrinking the network level test and the system test with the proactive shift left concept. Okay, but what this proactive shift left means actually, what we need to change in our mindset. Many times, again, people say that I can test, and again my example is performance, only if I can really measure the performance of the equipment on a real target system, target hardware, with all the configurations, with all the scaled up system. And only then I can say that the system will be able to handle this or that amount of calls or transactions. This is a concept of certifying the product. To certify it does what it should do. But I want people to find bugs earlier without certifying the product. Do you think you can find performance-related bugs earlier? Can you give feedback earlier on the quality of the product, removing faults earlier? I think so. And for that, we need a little bit different mindset. So let me give you an example. If we have a requirement to draw a red rectangle with this color code, can you test this for me? Do you need now an equipment to measure how red this is exactly? That would be a measurement. That would be like certifying your product. That would be like testing the performance or the capacity of your system. I suppose we don't need that, right? It's blue, so it's not red. So we find a fault. It's failed. The feedback is it's failed. Now if we go on, what would be your feedback on this one? Is this red? I think so. Is this the right color? I don't know. I need the measurement, the color measurement equipment to know that. But I would say it goes through my filter, it's red, my feedback, it seems okay. But I can give this feedback very cheaply and quickly. So this is red, that's the feedback. So. On the other hand, and let me see how better it looks like there. Good. Actually, this is the color code that we still need to measure. And if we measure, this is the real color code, what we want. So I believe that we focusing on feedback-giving mindset versus certification mindset, we can find a lot of faults earlier. Of course, this also means that at the end, still, we need to measure our product. But looking back to the should have been found profile of system verification, more than half of those faults were stated should have been found earlier. So actually, we are using very expensive environments to do some work that is not our work. We can reduce the effort a lot by finding those faults much earlier and not actually leaking the fault to that expensive phase. So the question is, how can we build this concept into our test strategy? So currently, if we look what are the chances to test our product, just to list the different testing stages, I would list the following. A specification review for reviews, so for static testing, static analysis of the code as well, component test, integration test, system test, and at the end, network verification or system of systems test. So typically what we do now is we focus more on the functionality. We focus a lot on that. We give feedback during the specification review mainly on functionality. Component test. We are running it against the code lines, right, the code coverage, but as well against the functionality of the module itself. We are not really checking for too much else. And then on system test, we focus more again on the functionality and there the performance as well. But actually, almost everything is just certified at the end. Sorry, at the end. from this concept with using the feedback giving instead of certification mindset, I would like to see that actually we get to this test strategy where we shifted all the things to the left. We give feedback earlier. We give feedback on earlier stages. And by the way, I'm not only talking about V model. Even in an agile area, we have all these testing possibilities, let's put it that way. Whenever you are asking back the user, the customer, are you sure? That's requirement specification review. Or if you just ask the business that, is this really the problem of the customer, what we want to solve? That's already testing, that's already shifting left, fault finding. So let's see how we can actually implement this and how we can create a test strategy in line with this concept. Throughout the last, I don't know, 2 years, I was traveling around in Nokia and had a lot of workshops with a lot of teams. Actually, having a much more detailed slide set, teaching them about this shift left and proactive shift left concept, but also asking them to pick one test phase, break it down to smaller goals. What is the goal of that test phase? Why you need it? What are the things that you are looking for? And then try to understand where you can capture those faults earlier on the left. Where you can find them. Actually, how would you be able to fill up that test strategy table? So based on that, as an example, I would like to show you one aspect, one list for performance testing. And one comment here that when I'm talking about performance testing a lot and all the illities and all the non-functional characteristics of the product, it's very important not to forget about them. Not to do only testing for functionality, but robustness, performance, security, usability, and all the others. Okay, operability, serviceability, maintainability. So with performance, we were able to generate the following table, and actually this is based on all the workshops, so I put together a lot of feedback from people. So how can you test performance in review? Actually, for review, we suggest creating checklists. I've seen root cause analysis of customer faults, that why this specification fault was not captured. And after asking the 5 why, we ended up saying that the expert was on vacation during the review. So he was not there to ask the right question. But my question is, why do you always need the expert? What you need is the expert's knowledge. Can we somehow translate that knowledge and put it in a knowledge management system? Maybe create a checklist? A checklist is something that you can update at the retrospective, regularly coming back. It's your learning base. You can use it really to have a chance for the expert as well to go for vacation. So in the checklist, you can put things like performance aspects identified, meaning that you are checking that the specification itself is dealing with performance-related issues. Capacity, performance, feedback time, everything, response times, everything what is expected. You can also make data validation for size. If you need to send a lot of data frequently, and you see that actually that data is huge, like XML files or HTML or any text-based things, it might be a problem for performance. It might be, something that later degrade your performance. Oops. Algorithm of, okay, sorry, this is a little bit echoing. The speed of your algorithm, so how do you actually, what algorithm you use? Okay, this will be a little bit stupid. Some months ago we found out that in a very important procedure we were using the bubble sort. That was developed like 100 years ago, at the time when we were still doing the booth. But now we scaled that algorithm up. It was created for sorting something like 10 items. And now suddenly it had to sort 10,000 items. And of course it was slow. So actually checking these things during the specification, you can find these kind of failures. Or bugs, let's call them bugs, they are. Expected response time. Is it actually defined what is the response time? Is it defined for a program block? Is it defined for a system? Is it defined for the whole systems of systems? If it's not defined, how do you know it's wrong? So at least you need to see in the specification if it's there. Then going for static analysis, so actually how to check the code itself. Also here, you can create coding guideline rules for performance. Maybe you can identify things that are, again, showing that there might be an issue. Data structure analysis you can do on the fly with the source code. In component test, typically we have a lot of functional component tests, right? They are trying to find bugs in the functionality. They are also trying to cover the lines, the source code. But actually, many times we are not measuring response time because we say that the unit testing or component testing environment is not the real environment. So why to measure? You remember, I cannot certify the product. But actually, if you are measuring the response time throughout the continuous integration, and you collect these as a trend, and you see that now your component is answering much slowly, then you might say that, hey, this is stinky, I might found a bug. And this might be a weak performance bug that you found early enough. So again, on the left. CPU load and memory consumption, also in component testing. And why this is good? Because you can build this into your environment. You don't need to change your test cases. But you can utilize this in the CI environment as well. On the system testing, actually, this is the area where you certify your product. So actually, this is where you run the full traffic profile. At least in Nokia, this is what we do. Loading and stress testing your system under test with a lot of transactions. But actually, even before that, you need to test every single type of codes if they are going through. Clean it out before you start the very heavy and very expensive testing. Sometimes we run test cases for 5 days. Sometimes the fault comes out only after 3 days. So it's really expensive and you need to restart it, and then your deadline is shifted as well. Shifted to the right, which we don't like. Okay, these were just some examples about what you can do. But actually the idea is that you come together, the whole team, and discuss through what you can do. You list your quality characteristics, all the abilities, all the functional and non-functional aspects of your product. And for all of them, you define how would you test them on the left. What would you do with them on the left? So actually, as a summary, I would like to tell you that for shift left, and especially for proactive shift left, you need to understand all the test phases. You need to understand the goals of them, why they are important. You need to also break the silos. I'm a functional tester. I don't care about performance. No, you care. You are in the team, and the whole team is responsible for the product, so you should care, and everyone should care about the quality. We need a mindset change from certifying the product to giving feedback on it. Whatever fault you found is an important fault. You need to give feedback about the quality of the product in as early test stage as possible. In this concept, you can do also a phased rollout. It's possible to focus on different quality characteristics. So starting with functional, moving that to the left, then with performance, moving that to the left, and security. So you set the goal, you set the priority, how to go on. And when you define this test approach, your test strategy, you can always collect leakage information, statistical data, and based on that you can come back and improve your test strategy. Improve how you do it, improve how you give feedback. This is what I wanted to share with you about the shift left concept. We did a lot of this exercise at Nokia. We had a couple of hundreds of smaller projects to initiate shift left actions or proactive shift left actions to move some of the testing to the earlier phases. I'm not saying you how much money actually we saved. Of course, we calculate everything, but there are quite a lot of zeros at the end. So it's really worth to do shift left. It's really worth to do it proactively, building it in your test strategy. And even you think it's an old concept, finally, it's just good to start using it. Thank you very much.
Thank you, Szilard. So, I'm actually from Ericsson, but I've worked with Finnish people. So you have a few questions, but give them Finnish answers, please. So, three words.
3 words, Finnish answers,
Yeah.
okay.
Let's go with the first one, which is, what is a good feedback on the earlier stages of the product lifecycle about performance testing?
I suppose I already answered this one, but if we really want to go on the left, ask the customer, how fast do you need it? How reliable do you need it? How much you will load it? So clarify the requirements for performance first.
All right. Our next question is good. How do you ensure that moving experts' knowledge into the checklists wouldn't end up with a checklist too complex to handle in a team?
This is a very good question. A checklist to be able to be used should be simple enough. This is why I said that actually at the end of the iteration, the team should own the checklist and the team should also update the checklist all the time. If it's 2 years old, it's already crap. If it's 1 year old, it's also not good. If it's 2 months old, okay.